Happy Friday, Year 10. So let's take a look at how we add and subtract with standard form. Again, we're revising last day of standard form, and then we'll move on to something different next week. Okay, there's two ways we've learned this in class. The first way, and the easiest way, is if the powers of 10 are the same. So if you notice, these are both 10 to the third power. That means these two numbers, if I were to expand them and make them ordinary numbers, they would have the same amount of place values. So I can actually, short term here, I could quickly just do this instead and save myself loads of time. So if I actually add the front numbers and get, 8.3 times 10 to the third, that is the quickest way to do addition and subtraction. But again, I can't emphasize this enough. It only works if these are the same. Okay, let me show you the other way you can do it. So the longer way to do this is actually to expand. So if I know this is 10 to the third, that means it's 3 place values larger. So I'd go 1, 2, 3. So that's 3,200 as an ordinary number, which means this one, think about it, it'd be the same amount. So it'd be 1, 2, 3. So this would be 5,100. You then add your ordinary numbers together to get 8,300. But then you have to put it back in standard form, 1, 2, 3. And then you would get the same answer I just got about 1 minute ago. So that's why this is way quicker. But again, if you forget and you're not sure, you can always go back to your ordinary numbers and convert. It takes longer, but you'll get there. It's fine. So let's check this next one out. Okay, notice again, look, the powers of 10 are the same, so you can actually do the quicker way this time. Pause the video, and let's see if you got it. Okay, let's find out. So I'm noticing my powers of 10 are the same, so I can actually add these as is. So I'm going to add 6.4 plus 2.5 to get 8.9, and then that would just be times 10 to the fourth. Boom. All right, now obviously what happens if these powers are not the same? So I'm noticing this is 10 to the 7th and this is 10 to the 5th. So I repeat, cannot add 6.2 to 3. It's because these are actually different amounts of place values. So this 3 might not line up with that 2 if I were to expand it in ordinary numbers. And in fact, it actually wouldn't, because this is 5 and this is a 7. So this is 2 place values smaller. Okay, so here is what you could do. You could turn these into ordinary numbers, like I showed you here, and then turn it back into standard form. Or you can go back to the skill we learned in the first lesson that we recapped about how you can manipulate these to make these powers the same. So what I mean by that is, if I were to make this, for example, 2 place values larger, I would have to make this 2 place values smaller, and then I would get 10 to the 5th. Let me show you what I mean. Okay, I'm gonna make this 2 larger. So that means to counterbalance and keep the same value of this number, this has to be 2 smaller. So this is equivalent to 620 times 10 to the 5th. Again, look, I meant 2 larger, so 1, 2, which means this has to come 2 smaller. And now look what I can do. I can actually go ahead and add the front numbers. So I'm going to do 620 plus 3 because they're both 10 to the 5th. I get 623. So it looks like this, 623 times 10 to the 5th. But again, this is not in standard form since this first number is not between 1 and 10. So I'm going to divide by 100 to get 1, 2, counterbalance, don't forget, times 10 to the 7th. All right, let's double check it. Ready? So I made this 1 2 smaller. I need to make this 2 larger. Perfect. Cool. Okay, can you please try? Oh, let's think about this actually for a second before I move on. Notice I manipulated the first number. You could have manipulated the second number to make that become a power of 7. So meaning I could make this 2 place values larger to make it 10 to the 7th. I would have just had to make this 2 smaller. and I could have added that way. So either works. It's kind of up to you. Can you try your best to use that same scale and do this one, please? Okay, let's take a look. So I'm thinking I'm going to make this one larger, which means this has to become one smaller. So the equivalent would be 0.3 times 10 to the fourth. And now because the powers of 10 are the same, let's add. So we end up getting 5 to the 7th. And it would be 5 to the 7th times 10 to the fourth power. And it's already in standard form. How great is that? Okay, last two. Now, same thing works for subtraction. So again, if these were both 10 to the third, or if they were both 10 to the fourth, we're on our way because I could just go ahead and subtract those front numbers. But in this case, we actually can't. So the difference between addition and subtraction, again, is it's easier if you actually manipulate this second number with subtraction, because if you think about it, you want this to stay as large as possible, so when you subtract, you don't get negatives and then get confused. So what I mean by that is, usually if you manipulate this number, it makes your life a little bit easier. So watch, I'm going to make this one larger, which means this has to become one smaller, so the number stays the same. So I end up getting that. Now that the powers are the same, I go to subtract the fronts. And I know it's 10 to the fourth, so my answer is 4.2 times 10 to the fourth. All right, here we go. Final question for today. Can you please pause the video? And when you think you have the answer to this in standard form, can you please go onto Firefly and select the correct multiple choice answer? Good luck.